Warning! Highly flammable compounds must be handled with care, any open flames must be completely avoided, the experiment should be performed in a well-ventilated area for safety reasons. Gloves, goggles, and lab coat are absolutely mandatory. Curcuminoids are a family of compounds presented in turmeric which are responsible for the characteristic yellow color of turmeric. The world's most commonly known is curcumin. Chemically speaking, is a quite interesting molecule as it has alpha-beta unsaturated carbonyls, which makes it a Michael acceptor. Is involved in an important organic chemistry reaction known as a 1,4 Michael addition. This reaction, followed by an intramolecular aldol condensation, is known as a Robinson annulation. Curcumin has another interesting property. Alcoholic solutions of curcumin show a nice green fluorescence. Materials and reagents required: about 10 grams of turmeric, 95% ethanol, 150 milliliters plus 100 milliliters for washing. A Soxhlet apparatus. First, a round bottom flask is placed and secured into the heating mantle. Then, 150 milliliters of ethanol are added in addition to some boiling stones to ensure a gentle boiling of the solvent. The Soxhlet extractor is then placed on top of the RB flask. A small cotton ball is then placed at the bottom of the extractor. Now, 10 grams of turmeric are packed into the Soxhlet extractor. Finally, another cotton ball is placed on top of the turmeric. Now the reflux condenser is attached to the upper part of the Soxhlet extractor. The water flow and the heating mantle are then turned on. Here you can see how the Soxhlet apparatus is filled as the reflux proceeds. Now let's turn on the UV light. You can clearly see the nice green fluorescence of the curcumin. Actually, my Soxhlet extractor does not create a complete cycle, but it is constantly dripping on the RB flask. This is due to the position of the siphon. It could be solved by increasing the reflux rate, but it works perfectly fine like this. Sometimes if the cotton is packed too hard, the siphon tube might get blocked and so the liquid does not flow, so it is important to use a minimum amount of cotton. Actually, fluorescence is a pretty interesting process. It can be defined as a type of chemiluminescence. Fluorescence is the emission of low-energy photons when higher-energy ones are absorbed by a molecule. When the incident photon reaches the molecule is able to excite electrons to high energy levels, then, this electrons loss part of its energy in a non-radiative process and then the remaining energy can be released as low-energy photons. Due to the non-radiative energy dissipation, the emitted photons are always of lower frequency than the absorbed ones. Only a few molecules are fluorescent. A molecule should be pretty rigid in order to be fluorescent. If not, it prefers to lose the gained energy by dissipation to the surroundings or to other molecules. Here you can see how there is a constant dripping of the solution through the siphon tube. It can also be seen how the ethanol is condensed in the first stage of the reflux condenser. Once the Soxhlet extraction is finished, the RB flask looked like this. The whole process took about 8 hours. Then, the solution is filtered and placed into an appropriate flask to remove the solvent. In the meantime, a minimum amount of the sample is dissolved in 95% ethanol and is placed in a spectrophotometer cuvette in order to run a UV visible absorption spectrum of the compound. The cuvette is then placed in the UV visible spectrophotometer. The spectrum obtained looked like this. The maximum absorbance was found to be at 420 nanometers, which is in accordance to the curcuminoid absorbance spectrum. Actually, this absorbance corresponds to An to pi antibonding and pi bonding to pi antibonding electron transitions, which is further shifted to lower frequencies due to extended conjugation. The majority of the solvent was removed using a simple distillation. The general setup looks like this. Here you have a time lapse on how the solvent boils out of the solution. The whole process took about 2 hours. The last amount of solvent was removed by flushing air in through it. Once it is completely dried, the crude curcuminoids product is a red-brown solid. Actually, the crude product is a mixture of mainly 3 components shown in the following picture. The different components were identified by running a TLC in a mixture of 7:3 ratio petroleum ether ethyl acetate. However, in the TLC only one spot showed up with a retention factor of 0.22, which is in accordance to the expected RF value of curcumin. The crude mixture could be separated in its main components by running a column chromatography. The final yield was of 1.10 grams of. Thanks for watching.